It started?
Yep, it started.
Okay. So this is lesson 5. Did anybody have trouble with part 1?
I'm so lost
I
that
watched.
I have no idea what's going on. I don't know why. Normally I get it. I don't understand any of it today. But that's me.
That's okay. At least we have a. It was a little bit more tricky for me too. I watched the videos a couple times.
We don't have to go over
What
lesson
about you,
1.
Beth? I can't hear you very well. I don't know if it's me. Okay. So should we just start with part 2?
Sure.
Okay. Let's see. Did anybody have a chance to look over this one? I did, and I started some of it. But I guess we can just go in order, and I guess we can just help each other out because it was a little bit more difficult.
Okay, I'm warning you, I really don't understand any of it. So my part will be not very helpful.
Okay.
But I'll do my best, I promise.
No, that's okay. I struggled a lot with it too, and so I'm thankful that we have the TA with us today.
I can't
What
hear
about
her.
you?
I don't know if she's on.
I can't hear her. Megan, can you hear us?
I can hear you guys. Can you hear me?
Oh, now I
Okay,
can.
yeah. Okay, yeah.
Okay.
What about you, Beth? How did you do? How did you feel this was?
I think I'm getting it.
Okay. So we'll just start with number 6. Beth, do you want to start with that one?
Okay. Here we are. So scores on the quantitative portion of the GRE are approximately normally distributed with mean. I put 150.8 and standard deviance 8.8.
Yeah. That came off the chart that we were given.
Yeah.
Okay. You can keep going. Sorry.
Oh, am I doing all of the letters?
I guess we could take turns because I guess some of them have a lot of letters.
So I'll do A
Okay.
because before it was just obvious.
Okay.
So what proportion of the people who take the quantitative portion of the GRE will score above 165? And I got 0.0533. Does anybody want me to tell you how I got that?
Yes, please.
Okay. So the sample that they give is 165. So what we do is we take 165 minus the mean, which is 150.8, take that answer and divide it by the standard deviance, which is 8.8, and you get the z-score, 1.614.
Okay, I got that part.
Okay, so then you have to put it into that, what's it called again?
The normal probability app?
Yeah, that one. So you put it in there, you put in the z-score at the bottom, and then you highlight only the very right side. So the white and the left side should be white, and then the right side should be blue, and it will give you the percentage.
Okay, so because it's a because it's a positive z-score, I put it on the right. Is that right?
Yeah.
Right.
And then also we're looking at what's greater than 165.
So all the stuff on the right?
Oh, okay. Yeah. So the right, it's if you look at it like a timeline, the stuff on the right will be the stuff that's greater than, and it's positive going greater than. So you shade to the right.
Okay, so how do you unshade things? Do you just click on it?
Yeah.
Yeah.
Mine's not unshading.
Hmm.
I can shade everything, but I can't unshade the right. Oh. I can't unshade the right. I can shade and unshade the left and the middle, but I cannot unshade the right. Any reason why that would happen? Is it because my z-score is in there? Because when I yeah, okay. We can keep going. I'll figure it out in a minute.
It should, no matter where the z-score is, you should be able to either shade or unshade each section. So I don't know what's wrong with that.
Okay.
Okay. Brenda, do you want to try number B or letter B? Number B.
Okay, yeah, I'll try it. So, because it's a 10th percentile, right? I want to put that in the area part at the top,
Yes.
and I just put 0.10, right?
Mm-hmm.
Okay. And so it says with their corresponding so the corresponding one, would that be negative or positive? Because I get 1.282, but is that negative or positive, or would it be both? What is it asking when it says the corresponding z-score?
So when it's 10%, you're going to start at the left and go up. Anything past 50% would be using the second z-score, the positive z-score, and anything lower than 50% will be using the negative z-score.
Okay, so since this is below 50, then it would be the negative z-score of 1.282.
Yes.
Is that right? Ah, okay.
Okay. C, what is the quantitative GRE score for a student who's in the 10th percentile? So you take the, let's see. So I have this equation. So I took so we're trying to solve for x here.
Mm-hmm.
Oh, is that is that what it means when it's asking quantitative?
Well, the quantitative GRE score, that's just like the score on the quantitative portion of the test. That doesn't really mean anything as far as...
So how did you know they're looking for X here?
Because they're looking for what the score is, and so if we already got the z-score in the last one, then we're looking for the corresponding score to that z-score. Yeah.
So you have to move the equation around.
Of the x minus mu over sigma. You just solve for x now instead of solving for z.
Okay.
Okay, so you have x, and then you have equals your mean, which is 150.8, and then you add on your z-score, which is negative 1.282, and then you times that by your standard deviation, which is 8.8. And then it comes out to be, I rounded it to 140. I don't know if anybody got the same answer.
Yep.
Yeah, I did.
Okay. Is Beth still there?
Am I? Yeah.
Okay. Did you get that answer?
Yes, I did.
Okay. Do you want to start with 7?
Sure. The mean speed of hydrogen at room temperature is 1,800 whatever that is,
Maybe meters per second.
Oh, meters per second, with a standard deviation of 600 meters per second. At room temperature, the mean speed of hydrogen, H2, particles is approximately normal with a population mean of 1,800 meters per second and 600 meters per second, the standard deviation.
Okay.
Yep. So do I do then, Kelly?
What?
Do I do B then?
You can do B because that one was super simple. Yes. Yeah.
Oh wait, is that you want Beth to do B?
Yeah. Beth can do B again
Okay.
because it was so easy.
What is the probability that a randomly selected particle has a speed over 2,500? Okay.
So this one we're trying to find Z. Is that right? Or no?
Mm-hmm.
Yeah.
Well,
to
find the
much-
probability, we'll need to find the Z first.
Okay.
Yeah, this is pretty much the same problem that I did last time.
Oh yeah.
Right.
Okay.
Mm-hmm.
So it's going to be 2,500 minus 1,800 over 600. And that is going to be 1.1667.
Okay. I got that same answer.
Okay. So then we put it into the chart thing. Highlight only the right side. And the percentage is going to be 0.1217.
Cool.
I got 1216.
I rounded it.
Oh. Okay. Thanks.
Okay, Brenda, do you want to do C?
For C, we're going to do the same first part, 2,500 minus 1,800, because it's, what is the speed that it's less than 2,500 meters per second?
Mhm.
So I do the first part, 2,500 minus 1,800 divided by 600, and we get the same 1.167. But I'm stuck after that. So do I put the 1.167 in the z-score?
Yes.
We want to put it in the lower part because it's less than.
Well, we'd still start at the higher end because it's positive, but we start with the positive z-score, and then we'd shade to the left because it's less than. So we want everything that's less than that positive z-score.
Oh, okay, that makes sense.
Okay. So then my answer would be 0.8784.
Yes.
Is that what you guys got? Uh-huh.
And another way to do this is to take the answer from the previous question and subtract that from 1. Because it's...
Oh, well, that makes sense. Okay. Because everything equals in this whole area would equal 1.
Yes.
Oh. Sweet.
I don't know why this one's messing me up. Okay.
Okay, D. What is the probability that a randomly selected particle has a speed that is less than 1,500? So you basically do the same thing. It's 1,500 minus 1,800 divided by 600, which would give you a negative 0.5. And so you'd put those, I guess, put that in the lower, and then you'd shade the left side.
Mm-hmm.
Is that right? And then it gives you an area of, let's see, 0.3085.
Yep.
Cool. That's what I got. I love when I get the same answers as you guys.
Yep, that's what I got. My turn again?
Mm-hmm.
What is the probability that a randomly selected particle has a speed that is between 1,500 and 2,500 meters per second? Huh. So do you have to get the z-score for both of those?
Well, we've actually already gotten the z-score for both of these with the previous questions, so we can just
Right.
use the answers that we got there with this answer.
Okay. So we take the z-score of 1.1667.
Okay.
Percentage, and then we take the z-score of -0.5. We have to subtract something.
Okay, so we want what's between 0.3085 and what's between 0.8783, is that right? Because we want the middle, so we already found the outside, so we want the middle of that. Is that right, or am I wrong?
No, I think you're right.
I think you're right.
So
No.
do we subtract one from the other?
I believe so. I think it'd just be easier to take the bigger number minus the smaller number. If it doesn't matter which one. I guess. So if we take 0.8783 minus the 0.3085.
Oh, right. And then you get 0.5698.
Okay, that's
Yeah.
what I got. So that's our new z-score that we put into the applet?
No, that's just the probability, because the numbers that you're subtracting are the probability, and so you're left with the probability.
Oh. So that's all we need?
Yep. So what you just did, just so you can understand, like sometimes you're like, I know what I just did, but I don't really understand why or what. Trust me, I've been there. I know. What you just did is you took the less than 2,500 and subtracted the less than 1,500, and so then you're left with the stuff that's more than 1,500 but still less than 2,500. And so we'll have lots of other problems like this that you'll have to like do. Okay, well, I want more than this and then less than this. Then you just have to figure out which ones you're gonna subtract. Does that make sense?
Yes.
Yes.
Ish. So where is the 2,500 on the applet?
The applet is the 1.1667 z-score.
So the
And so if you're
100 doesn't go on the applet at all.
no, you don't actually put the 2,500 in the applet. You have to get the z-score and then put the z-score for that in the applet.
Okay. The z-score is the never mind. Okay.
Go ahead.
The z-score I have in my notes as being the area. No, hold on. Let me find out the definition. It represents the number of standard deviations the value is away from the mean.
Yes.
Okay, so the z-score is how far away So it could be like 3 standard deviations or 2 or 1.5.
Mhm. Yeah,
Okay.
exactly.
Okay. So a z-score of 0.5 means it's 0.5 deviations away from the mean.
And if it's positive,
Yeah.
that means it's 0.5
Yeah.
higher than the mean.
Okay. All right. Sorry, I'm trying to catch up here.
Oh, no,
No,
it's okay.
that's good.
Ask your questions. It helps.
Yeah, it helps me too. So.
What are we on? D?
I think
F, right?
we're on F. Yeah.
Oh, all right. Okay. What is the third quartile of the speeds of hydrogen at room temperature? The third quartile, that's at the 75% mark. That's Q3, right?
Mm-hmm.
Mm-hmm.
Okay. So how, so I can put on the area, I put 75%.
Yes.
Oops.
Oh yeah. Just type it in 0.7500.
Does that give me my percentage? Oops. It's not doing it. Okay. So mine is blinking from yellow to blue. Why does it do that?
I don't know. Do you know how to share your screen?
Yeah.
You could do that, and I could see what you're looking at. And
Yep. Okay. Hold on. Okay, here's my little applet,
mm-hmm.
and I point 0.75, right? Because that's 75%.
Yes.
And then it's blinking from yellow to blue. And I try to, of course, now it works. Same thing I've been doing for the last 2 minutes. Okay.
One thing to make sure that whenever you're doing percentiles is you want to make sure that the left is shaded, so that whenever it's doing the area, it's doing the right area.
Oh.
So, like all of the left or just the very far left?
It doesn't matter. Once it'll change it if you need all of it.
Okay. That may be it, because I think I may have had the wrong thing. Okay. You may have your screens back.
Wait, I liked looking at it. I don't have my own because I'm on my phone.
Oh, do you want me to put it back up? Ow! Do you want me to put it back up?
I'm on my phone too.
Okay. I'll put you back on.
it.
Oh, sorry.
Okay.
It's thinking. There you go.
So then the answer to that question is the z-score, right? Wait.
0.674.
It's actually, the answer for this question would be the actual speed. So we need to use the z-score and put it back into the
Oh, is this
Mine is all for
equation.
the x equals u plus z times q?
X
Yeah.
yeah.
equals-
I think so.
So then we have to find x again.
Okay.
So x equals 1800 plus 0.674 times 600. Is that what you did, Brenda?
We don't have.
I don't know.
I'm trying to figure. We don't have to divide it by anything, do we? Or I guess it would be.
I don't know what I'm doing. Okay,
You got
you
18
can see
grade.
my z-score, but can you see my preparation assignment thing here?
No.
You can only see my z-score.
There's a way you can share all your screens instead of just one particular screen.
That's okay. I would share the rest of them, but I'm pretty sure most of my stuff on there is wrong, so you guys don't even see that.
So yeah, the equation for x is z times sigma plus the mu, or the mean. And sigma is the standard deviation. So z times standard deviation
Okay.
plus the mean.
Okay, so 75th percentile.
Mm-hmm.
Is x, which is that the 5.698? Oh, I don't.
So you'd use the 0.674 for z, and then you'd use the 600 for the standard deviation, and the 1800 for the mean. So it'd be 0.674 times 600 plus 1800.
Oh, okay. So x then equals 2204.4. Yes.
Yep, that's right.
Yeah.
Sweet, that's what I got.
Okay.
Okay. Determine whether the data represented in the QQ plots are normally distributed or not.
Okay, I
It's
don't
my turn.
have the QQ plots on mine. Does someone else have it? And
I
You
can.
don't have them?
yeah, it pulled up with the big red X saying this image cannot be displayed on your computer.
Oh, no.
Here, let me see if I can share it.
I'm really sorry, guys. I'm making this week's go really slow.
No, you're totally fine.
So can you see it?
Yeah.
I see that.
Okay.
So, whose turn is it?
I believe it's my turn. You just went, Brenda, yeah?
Yeah.
So plot A, it's not normal, basically because it goes straight up.
Yeah.
But it's all in a line. It will, except for the few on the outside. So, to be normal, they all have to be on the same line?
Yes.
Yeah.
And because this like starts going this way and then turns,
Okay.
it wouldn't be.
Beth, do you want to take
So
B?
then B's not normal either.
No, it would not be normal.
No.
Okay. So C's not normal either, because that's really funky.
See, this is where it gets kind of tricky. If you were to like zoom out or have a lot of that, that would still look roughly
In line.
kind of, it's still in a line-ish. It's like it's a squiggly line, but it's still a line.
In
So
the same direction. So then that would be normal because it doesn't go sideways and then up. It has a main basic curve.
yes,
Okay.
it has a basic straight. I mean, like it's not completely straight, but it's straight enough.
Ooh, I like how you have the answers on there. I can take D too if you want. Just kidding.
Okay. For plot D, so that would be normal too then, since it's just like slight changes in it.
Mm-hmm.
Okay.
Plot B. Well, it kind of goes back to where it was, but it could be not normal because it's not. I don't know.
So if we zoom out, would that,
What?
if we zoom out, would it look fairly normal?
It would. Yeah, that's
Okay.
well.
Because I guess thinking about what Megan said about zooming out makes sense.
Yeah.
Okay, so for some of these, it's kind of open to interpretation. On the key, plot E is not normal, and I don't know. There's sometimes I'd have to disagree. Like that could be considered normal, but usually you won't have any like on a test or something that's like, well, that could be normal, but I'm not really sure. Usually it's going to be more drastic, like, you know, A. A is definitely not normal. It starts going this way and then changes this way.
Right.
But
More obvious.
Where F is definitely normal.
yeah, F is definitely normal. There's no if, ands, or buts about it. It's normal. But E is more of a gray area where I'm not sure.
Okay. That's fun.
Like looking at it, I would say it's normal, but the key doesn't, so I'm sorry.
Yeah. So I just pulled up the answer key and to look at the explanation, and it says the downward curve suggests that data are skewed right.
Okay. So I guess this trailing off here, that's where it's
Not normal.
mhm.
Lovely.
Okay.
But usually it's going to be more black and white than that. That's very gray.
Okay.
That would be nice.
Megan, do you know if we are supposed to record us going over the quiz or if we're supposed to stop recording and then go over the quiz together?
No, you still continue recording while you go through the quiz.
Okay. So do we start the quiz now then, ladies?
Mhm.
Oh, sorry, Kelly. I'll be quiet.
No, you're good. No, you're totally good. So, yeah, we
Okay.
can start the quiz. That's in week. Are we in week 2? Yeah. Okay.
Make sure it's the group meeting quiz.
I know. Lesson 5, group meeting.
I've never done that. Gosh, I hope this is a short quiz.
Not really. It's not the shortest, but it's
We've got 18 questions.
Can I start? Because I read the first question.
Yes.
Yeah. Oh.
I mean the third question. So the total under a density curve must equal 1. I know that one. Woohoo!
Okay, let me see here. I should probably get my notes out. Okay. Number 4, under certain circumstances, the density curve can drop below the x-axis. That's false.
False.
Oh.
A normal density curve is symmetric. True.
Okay, good. That's what I think. Okay, using the following image to answer questions 6 and 7. Which of the following elements of the figure represents the z-score in this image? And that would be C.
Yay.
Alright, 7. Which of the following elements of the figure represents the probability that the z-score will be greater than 1? Is that the area? So, would that be A? Or is it?
Greater than 1? I
Oh,
would
greater-
probably say that's B.
That'd be B, yeah, sorry.
Maybe B. Because the z-score can be greater than 1, but the density curve, all that stuff in there, is not more than 1. That's the area, right?
Right. So
Right.
it's B.
Okay.
Okay, so it's me. Right?
It's
I
Ben.
think we should make Megan do some of these. Okay. According to the 68, 95, 99.7 rule, what proportion of the data from a bell-shaped curve will be within 1 standard deviation of the mean? And that's 68. Is that right?
Yes, that is.
Woohoo!
Okay, I'll go. Suppose that z-scores come from a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from this random variable will be between -1 and 1?
Okay, so we put 0.389 into the applet.
Wait,
No, you'll just put 1 into the z-score and make sure that the middle is shaded.
so I can't do that because I don't have my app.
I don't have it either.
Here, guys, I got it. I got it.
Bread to the lifesaver.
Okay, so I put 1 in the z-score here, right?
Yes.
And make sure my middle is shaded. Whoop.
Mhm.
See? There you go again. My blinking ghost here. Okay, there we go. Is that what we want? Oh, and shade the middle. 0.6827. Is that what we're looking for?
That is.
7.
Here.
Okay.
Make sure that it's rounded to 3 decimal places.
Okay, so it says
So 0.683.
0.683.
So this one is also needing the normal applet.
Okay. Suppose that z-score, what proportion of the values from this random variable between 2 and -2? Sorry, let me do that again.
You're just fine.
I should just leave this on screen share so y'all can see. Okay, so 2 and -2. So I have to put 2 here.
Mhm.
So is that we're looking for the area again, 0.955?
Yeah.
What was that again? Sorry, you broke out.
So we do between 2 and -2, so that would be 0.955, right?
0.955. So these are pretty much all the 68, 95, 99.7 rule answers.
You are right.
Yeah, it
so,
is.
okay, point.
So the last one is -3 and 3.
Okay, so oops, here we go. .997. Who saw that one coming?
So the next question would be the values match the 68, 95, 97, or 99.7 rule.
Yes, it does.
That's sweet.
Oh, I should have left it up again, huh? Okay, the amount of protein that an individual must consume. Oh, it is my turn, right? Sorry.
Yes.
Okay. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram of body weight. Right. The population mean protein requirements for adults is 0.66 grams. P times kg minus 1 times, okay. The population standard deviation. Use this information to, okay, answer 14. What? So what proportion of the population have a protein requirement that is less than 0.6 g? Give your answer as a decimal.
Is all these letters supposed to mess us up?
So they use the same questions for social science stats as they do for the biostats, and this is more something that biostats people might understand. I don't know what it is. I think it's, yeah, I don't.
Okay, so all of the P times kg negative 1 times D negative 1, doesn't mean
That's just like a unit of like what they're talking, like what they're measuring. So
we could take all that and just say that equals X.
Yes.
So
Like
okay,
that goes in with the
our own
grams.
Was the proportion of the population have a protein requirement that is less than 0.60 g? So my 0.60 g is my x. So I'm trying to find z. Is that right, you guys? And then I put that in?
Yes.
Okay,
This
so
sounds right. Yeah.
So using my...
Wait, is the 0.60 that's the X looking thing?
Yes.
The sample, I guess, is what it's called.
Mm-hmm.
So z is x minus u divided by q. So x is 0.60 minus u, which is 0.07, and then divide that by...
So the mu is not 0.07.
No, the q, what do you call that little upside down q is 0.07.
Yes.
Yeah. So that's the standard deviation.
The mean is let's see. Wait a minute. 0.66 minus
No, you'd still do 0.6 minus 0.66.
0.66. Okay. Okay. So
Hmm.
0.6 minus 0.66 divided by 0.07 equals, I got negative 0.857 as a decimal to 3 places, so it's 0.8571 is what I got, so negative 0.857.
So that's the z-score.
Oh,
We're
right.
looking for the proportion.
Right, so now I put the z-score in my thingamajigger. And I put in
Oh, wow.
8.57 here. So, wait. What are we looking for? What proportion of the population? So we are 0.608. No, 0.609, because it would be within the 68% of the population, because it's within the one standard deviation, but we're not quite all the way to the one standard deviation. So is it asking for 0.609 because that would be the population?
So we're looking for what's less than 0.6, and that's
Over.
the z-score is less than, or the negative. So we'll, yeah, like that, exactly, perfect.
Okay, so a less than would be 0.1957.
Yes.
So that would be 0.196.
Mm-hmm.
Okay.
0.196. And then if it was more, then it would be on the others. Oh, that's the next question. Sorry.
Yeah. No, you go ahead and answer that one because you have the app.
Okay,
yeah, you have your little app thing.
So the more than would be basically the same thing, wouldn't it? Because it's equal. So 1.196.
Well, we'd still have to start at the negative z-score, so we'd shade the middle and the, yeah, like that.
More than that, so it includes everything, which would be point.
Wait, I don't think it's the negative z-score. They say more than.
But it was negative. It's the same. It's the same information that they just gave us.
Yeah, 0.6 is less than the mean, so we're going to start lower than the middle and then work our way up.
Okay.
So it would be 0.804.
Mm-hmm. And also another way to do this is to do 1 minus 1 or 0.196, and that would also give us the 0.84. 0.804.
Okay.
So should this be a 3? No.
So for number 15, I did the calculation already.
Okay.
And 0.7 minus 0.66 divided by 0.07 equals 0.5714.
So that's my z-score, and we're looking for less than, so I need to shade here. Sorry, what was that number again?
0.5714.
And that's positive, so that would be these two right here, right?
Yes.
So our area would then be 0.716.
Yep.
Perfect. Hi, Susan.
Okay, so
I can't hear you, Susan.
I hear you. Hi, Susan.
I still can't hear.
Oh no. Dang it. Okay. So number 16.
we're almost done.
Find the probability that a randomly selected person will have a protein requirement that is between 0.60 and 0.70. Remember that to find the area between two values, shade the left of each z-score you calculate and then subtract the smaller area from the larger area. Make sure your answer is positive. This is a probability that a randomly selected observation will lie between the two values. Okay, so we take.
So we have to minus 716 from
804?
196, right?
Or let's see.
Or do we do 0.85? No, that wouldn't be right.
I mean, we subtract 0.196 from 0.716, right?
I think so.
Yeah, it'd be 196 from 716. because they're both going less than.
So 0.716 minus 0.196.
Would be 0.556. And then I put that into this. And I shade the left.
Actually, these are both already the probabilities, so it's given you the probability.
So the answer is 0.556.
Okay.
556.
Oh.
I'm gonna check my math real quick because that's not what I got.
But we do take
Point
7.716 minus
minus
97.
0.197.
That's the left side, that's Q1 and lower, and then Q3 and higher, and we're looking for the middle, right?
Okay, I was using 0.196, so that might be why.
But it's 0.197.
I would use 0.196.
Okay.
Just because that's just to make sure that you have it right.
So it'd be 0.52.
Mm-hmm.
It'd be 0.552, you said?
No.
Just 0.52.
Sweet.
0.52? What?
I'm a little lost.
Because
Okay.
you take 0.716 minus 0.196.
Mm-hmm.
And that's 0.52.
Yes.
Okay.
Okay. Okay. I think it's my turn. Find the 35th percentile for protein requirements for adults.
So then you go into the top of the chart and type in 0.35, right?
Yes.
So, we're looking for the z-score.
Yes.
That is 0.454, it looks like.
Once again, you'll need to make sure that you start at the left whenever you are doing percentiles.
Okay, hold on. Let me think about this. Find the 35th percentile for protein requirements for adults.
So only the left side is going to be shaded, is that right?
Yes.
So it's because it's below 50%.
Okay.
So that's 0.358 by shading just the left here. Does that look right, you guys?
Yes, that looks right.
Yes.
Okay. 0.358.
And then find the 80th percentile.
So if it's above 50, then I shade both
You
of
would
these.
still shade this left, and it will.
Like this? Or do I shade the
No.
middle too?
You just shade the left, and it will adjust appropriately.
Okay. So then that would be 0.842.
And both of these are just the z-scores, so we'll need to put them into the equation to get the actual protein requirement.
Oh, okay.
And that's our x equation,
Yes.
right?
Mm-hmm.
So our x equation is x equals u, which is
So 0.358 times.
okay. So the u is 0.66.
Mm-hmm.
Okay, so our u's got to go first. So x is equal to u, so it's 0.66, and then plus z, which is on the top one, 3.358, times our standard deviation of 0.07. Does that sound right? So my
0.66 plus 0.358 times 0.07.
Yeah, so you'll need to multiply 0.66 times the z-score and then add the sigma. Is that what you're doing? I add the standard deviation.
Wait, we're adding the standard deviation?
Oh wait, no, sorry, I'm sorry. Forget what I said. Multiply
okay.
the z-score by the standard deviation and add the mean.
Okay.
Right? Is that what it is?
I'm not sure what you're saying. So the equation is x equals q, or I'm sorry, u plus the parentheses of z times q. So
Yeah, okay. Yeah, that's right.
okay, so it's for the top one, it's x equals 0.66 plus parentheses 0.357 times 0.07 in parentheses. And so I got 0.685. Did anybody else get that?
I got something slightly different.
What'd you get?
I got 0.633.
Okay, tell me your numbers again.
So you take
Sorry, I just did number 18, so I don't know what the number is.
It would
a negative 0.385, and you multiply it by the sigma, which is 0.007, right? I'm looking back to make sure.
Okay, so you did negative 3.385.
Yes, because it's a negative z-score.
Because it's 35 percentile, so that's what I did differently.
Oh.
So
Negative 3.8.
try that again.
Okay.
Try that. Let's see if I get it. Plus negative 0.385 times 7. I got 0.633 this time.
Okay, perfect.
So on number 18, I did 0.842 times 0.07 plus 0.66, and that was 0.719.
Yep, that's right.
Awesome.
0.719.
So, are we ready to submit?
I believe so.
Okie dokie.
Here we go.
Beth, do you have any last minute comments to make sure we all get the right answer?
No, I don't.
All right. I'm submitting. Hooray!
Yay! 100%.
Do you guys have any other questions for me?
I don't think so. Thank you, Megan, very much for all of your help today.
No problem.
Yeah, today was a good day.
If you have any other questions, please feel free to come into the office hours. A lot of times it's just me and my computer. No one comes in. Also, feel free to email me or anything. So you guys seem to be doing awesome. I'll meet with you guys again sometime about halfway through the semester once I've met with all the other groups once. But keep it up.
Okay.
Awesome. Thank you.
Thank you.
Thank you.
Bye. So I'll go ahead and post this. I'm sorry that Susan didn't get on